Good evening, everyone. My name is Ranjan Kathuria, and thank you, Nikita, for the introduction. I am here to present my talk on building a cloud native, or I would say a secure cloud native private CA with OpenSSL and a cloud-based hardware security module. In nutshell, we are going to talk about making sure to build a secure, scalable, self-service PKI based architecture. Just to give a little introduction about myself, I work as a staff security engineer at Rubrik, which is uh, uh, a leader in data backup and data security domain. I lead the cloud security engineering team, and I reside in Palo Alto, California. I have over a decade of experience in building cloud engineering, like services over cloud, and doing, I would say, secure architecture reviews. And outside of work, I like to contribute in the field again of cloud security, identity and access management, and areas like golden images. And I'm sorry, there's some background. Uh, there's some background noise. I can hear back the moderators. Can someone please fix that? Thank you. Uh, uh, I can hear back a lot of noises. Can some moderator please fix that? Okay, thank you. So jumping to the topic of discussion today, and then which is the PKI challenge in modern enterprises. And please feel free to interrupt me if you have any questions. And if I talk about something that doesn't make a lot of sense, then it's not me. It's probably 4:30 a.m. in San Francisco, so it's lack of sleep and not me. But jumping straight to the problem, so the PKI challenge in modern enterprises. One thing that all of us will agree on is that the idea of building a monolithic service is slowly, I would say, uh, you know, is slowly going down, and the adoption toward building or moving to a microservice-based architecture is rapidly increasing day by day. And to this thing, since the microservices based architecture is rapidly increasing, it is also sort of bringing a very interesting challenge and a very interesting problem to solve, which is how you would manage the certificate and lifecycle management, which means the issuance of certificates, the revocation of certificates, the management of certificates, and the whole certificate lifecycle management. In my prior experience, I have had a chance to participate in a lot of bug bounties, and then the thing that I have seen in past is that while people are adopting towards microservices based architecture, the the simple, I would say, problem to solve, which is to make sure that your service is always on, is as an example, it's not using an expired certificate, or your certificate, or your service is not using any certificate at all. So these problems would eventually most of the time lead to compliance failures. And the whole idea of doing a PKI in is to basically, or the whole idea to solve this would be a centralized, secure, and an automated way to basically build a private certificate authority. Now, I am pretty sure that most of us will have a question about, hey, why an internal CA? What is so special about internal CA? Why not public CA? I mean, what's wrong or what's bad with public CA? The short answer here is that there's nothing wrong with a public CA. There's nothing wrong or there's nothing bad with a public CA. But the whole idea of, if what I feel like is, if your service is internal, and then if your service to service communication, it makes a lot of sense to build and to rely on a private CA rather than going to a public CA. Which again, since I talked about the certificate and lifecycle management, things like revocation, security policies, custom time period, and then what algorithm to use, and then the whole idea of, I would say, building a self service that can issue, revoke certificates without manual bottlenecks is I believe somewhat easier in when it comes to internal CA rather than directly jumping into public CA. And of course, if done correctly, it is simple and it is secure, and it has saved quite a few like amount of dollars in our use case. Now, this is still a to-do for me, but I mean, I've been working on this for long. But the whole end state vision that I have with this is that, the idea of having an isolated root CA for maximal security. Now, what we can, also think of here is that everyone is trying to solve the challenge of, let's say, if the whole root CA is compromised. I mean, if imagine the scenario that you are on a public CA and then the root CA for them, it has been compromised. There has been research done on areas like public key pinning, making sure that you pin, you have this header for your services and things like that, to make sure that even if the root CA is screwed or is gone, then it produces a minimal impact on your service. But in our architecture, like while we build an internal CA, the whole idea of having an isolated root CA is basically a P0 is on top. And after the root CA, I would say an HSM protected intermediate CS for all the operational activities. And then, fully automated, I would say end-to-end workflow-driven certificate creation and delivery. And I would say, since we are talking about security, because certificate is part of, I would say, making sure that your services are secure and trusted. The you know if we do not talk about the monitoring, we do not talk about the management of certificates, then that is, I would say, injustice towards building the service, right? So the whole idea of making sure that every certificate is monitored, the expiration time is monitored, promptly flagged. This is something that comes in our end state vision. And as I mentioned in the previous slide, that you know if you are using a public CA, then making sure to build and to give a self-service portal to your users to get certificate at any time they want. I would say it's little, I would say, problematic. But what we will try to do is we'll try to solve it by building a self-service portal, not portal, but a self-service solution to seamlessly issue, request, approve, and reissue certificate. Now, coming to the high-level design, the idea, as I mentioned in the last slide, was that our root CA should be isolated, right? And then for this, what we are going to do is we're going to pick a FIPS. FIPS is basically, most of us are aware of that. It's Federal Information Processing Standards, but we'll pick a FIPS based HSM in cloud. Like you can, for this, I've taken AWS as an example, but you can pick any HSM you want in cloud, be it GCP or be it Azure. So, but for the root CA, for our high level design, we'll pick AWS CloudHSM, and then we'll use OpenSSL library to issue a root CA issue a root encryption key that lives within HSM, and it becomes whole isolated. So you will deploy this HSM in a VPC in a subnet that has, I would say, no egress connection and limited in ingress connections as well. So the VPC is isolated. On top of that, your root encryption key that you have generated using OpenSSL library within HSM lives in HSM. So that talks about your root CA. Now, for the intermediate CAs, the idea of building an intermediate CA is basically using a vault that can have a PKI based engine. And then you can pick any vault in this scenario. But for this presentation or for this talk, and for our use case, we picked HashiCorp Vault because it supports PKI based engine. So after building an isolated root CA, we will have a vault that can either live in the same subnet or in the same VPC, or it can live in a VPC that is paired with the HSM VPC, and then you can have n number of intermediate CA. So basically, there is a root CA that signs the intermediate CA1, that signs the intermediate CA2, and pardon the typo here, but at the end of the day, you would have a leaf certificate. So the high level design is basically there's a root CA that signs intermediate CA1, then you would have n number of intermediate CAs which would sign like CA1 will sign CA2, CA2 will sign CAN, and then at the end of the day you would have a leaf certificate, and then the user who's requesting would be presented a certificate chain. Coming to the low level of design, how exactly we are trying to solve this. Now we talked about having the need of a FIPS based HSM, cloud HSM, and then how we have used OpenSSL library to build a root encryption key and a root CA that lives within HSM. Of course, the vault has been deployed, and then that act as an intermediate CA which will sign our leaf CA. But the idea of deploying vault is that you know because HSM works with a crypto-based user, the whole idea of putting them in a network that has peering with each other is to make sure that anytime if the PK Vault PK wants to so the way crypto user works is basically it has read access, again just the read access to get the references out of HSM. It can never again extract the whole root key, but it can get the reference to the root key, which can be used by Vault if an HSM client is used within OpenSSL to basically sign the intermediate CAs. Now, at this point of time, we have sorted our root CAs and our intermediate CAs. But if I go like 2 slides back, the whole idea of building a self-service, how that is solved. And since we are dealing with AWS, I'm going to pick 3 to 4 or 5 services that I have used in this scenario to actually solve the self-service problem. The first one is API gateway. The second one is Lambda. Third one is parameter store, KMS, ACM, which is AWS Certificate Manager, AWS Event Bridge, and then DynamoDB. And then we'll jump into these in detail now. So the end state vision, if you remember, is basically building a self-service portal. Now, what happens is that for this user, the front end for this service lives in Amazon API Gateway, which means that a user is presented. Like think of this that I come as a user and I ask the service that, hey, service A, build me get me a certificate for abc.example.com. Then at this point of time, I am hitting an API that has been presented to me by API Gateway, where my code runs that does the further step. Now, the most important part is that how we authenticate this API gateway, or how we authenticate and authorize these API requests. And the whole idea of doing that is basically building a Lambda authorizer. So Lambda, as we all know, is a serverless component. What it does is, you would have your authorization code where you'll use, let's say, JWT based tokens, and then again, if you're using services like AWS Cognito that has the identity pool for AWS users. Let's say if I Ranjan, and I'm allowed on AWS account A, I have an access role B, and I am allowed to use this service, then all sort of logic would eventually go under this Lambda at auth. So at this point of time, my user is authenticated and my user is, I would say, authorized to use the service. Now, this Lambda triggers another Lambda, which is PKI Lambda. And that's where all the magic happens. So again, we will rely on OpenSSL library. And within this PKI Lambda, we'll do two things. We'll first build a CSR for the leaf certificate. In this case, would be abc.example.com. And then we now need to hit the vault. So vault can act as a secret manager as well. But in this scenario, you need to go and reach out to vault PKI here. So you've the details and then the details around what the address of the vault and then what token to use would live in a parameter store that has been encrypted by AWS KMS. So this PKI Lambda, after building the CSR, would go to parameter store and would ask, hey, parameter store, give me the address for the vault and give me the token that I can use to authenticate to vault. After the service gets the token, it would then send the CSR, the TTL, the all the required details to vault intermediate CA, to the vault PKI engine, and then vault will issue a certificate and will give the response back in JSON to the Lambda. Now, once the response or the certificates are given back to this Lambda would trigger another Lambda, which we call here as certificate import Lambda. What this will do is this will trigger an API call to Amazon Certificate Manager. Why this is important? Now you can end your service right here. You have the certificate, your client is happy that they have received the certificate, but the whole idea of again building a self-server is to make sure that the certificate is managed as well. So you would hit this certificate import Lambda will hit ACM, which is Amazon Certificate Manager, to import the certificate. Now again the certificate now is imported. Again, you can call it a day here, and then you can just say that, hey, my certificate is built, it is pushed to ACM, and now it is managed by ACM. But what we still want to solve is, what if the certificate gets expired? Now, to solve that, what ACM does beautifully is it triggers events. For any certificate, it triggers event, let's say X number of event in Y interval, that, hey, this certificate is about to expire in X number of days. Then what we'll do is we'll use an event bridge, AWS event bridge, and as the name suggests, this just creates bridge between two services. So here ACM is pushing or public, I would say, publishing the events that, hey, this certificate is about to expire. We'll use an event bridge which will capture the details, and as soon as the certificate is about to expire, let's say in X number of days, it will pick that, and then it will trigger another Lambda, which is certificate expiry Lambda. So let's say if your certificate is about to expire in X number of days, Event Bridge will get the details and then would transfer it to certificate expiry Lambda, which then would do two things. One is I am calling a DynamoDB here, which means I'm storing the details of when my certificate is about to expire. The second thing that you can do here is, which again, I beg your pardon, which I have not mentioned in this design, is you can integrate services like SNS, which is a simple notification service, and you can actually hook it up to your Slack, to your PagerDuty, and to your emails, and you can get an alert about the moment your certificate is about to expire. And for this whole service, the logging is so much crucial. Like we should have logs generated at each and every step. So you would use something like AWS CloudWatch, which will capture all the logs, which will capture all the details, and then would gather those logs for the further investigation. So at this point of time, we have a front end, we have a user is able to hit API gateway, get itself authorized. Then there's another lambda which can build the CSR and get details from parameter stored, then hit the vault PKI engine, generate a certificate, commit back to PKI lambda, then it will store the certificate to ACM, which is Amazon Certificate Manager. Then there's another lambda that can track the expiration period of this, and then it can publish the event to SNS and things like that. What you could do more here is that the moment your certificate is about to expire, the service can again use and hit the PKI lambda to reissue a certificate. So let's say if your certificate is about to expire in X number of days, event bridge got the detail, it triggered another lambda. So the lambda would then make a call to PKI lambda, and the lambda would again generate a CSR, would hit the vault PKI engine and then get the certificate. And then using this, you have built an end-to-end certificate lifecycle management, which can build the certificate, which can issue the certificate. The PKI provides a way to revoke the certificates as well, and then I'm going to talk about in next further slide as well. But this is the whole idea of how you can have an isolated root CA, then you have intermediate CAs, and then you can build an end-to-end certificate issue and revocation solution. Now I've been talking about FIPS a lot. What's the advantage of using FIPS level 3 based HSM, and then why it is so special. The whole idea of having an isolated root CA becomes very crucial, and I've been stressing lot and lot on the if you see the first part here, which is AWS HSM plus OpenSSL. I've been stressing a lot about this. That is where the FIPS become really important, because areas like temper detection, areas like loose access control, areas like role-based access, multi-factor access, and then making sure that at any point of time your root key is non-exportable, that is the basic deal that you get to solve with a FIPS level 3 validated HSM. And the idea of having an operational trust that can make sure that organizations are I would say feels confident about their root keys not leaving out of the HSM, and nobody would even within the org would get ever access to the clear text encryption key is very important, and that gets solved by using a FIPS based HSM. Again, it is trusted by the regulatory bodies of things like FinCare, healthcare, and government. And then the whole idea, again, you can use any HSM that exists here, but the whole idea of using a cloud-based HSM is to make sure that the API driven operations are pretty much easy when you're dealing with cloud-based HSM for automated PKI workflows, while making sure that all the access controls are in place. I'll quickly try to wrap it up. So we have a secret root key generated in HSM using OpenSSL. Then we have Vault that deploys the intermediates. HSM signs them. Then intermediate CAs are used to generate the certificates on user request, and then the private keys, the leaf private keys, basically delivered with the strict access control. And this is basically the critical part. So I've been talking about this design. If you see here, all the API gateway and then things like that. So let's try to quickly jump a little bit, in depth for this thing. The whole idea is to basically have an API request initiation, which means there would be an internal application or user that would make an authenticated API request to your certificate service. In this case, the certificate service is basically that Lambda or basically the Vault PKI engine. And then the request contains details around domain validation and then validity period, usage, what TLD it is, and things like that. And you could, in your PKI Lambda, you would add a logic to check a TLD, because we do not want our user that only has access to generate example.com certificate to generate a certificate for, let's say, example1.com or something like that. And then we'll have an input validation and authorization that we just talked about, and then we'll generate the CSR on behalf of the user. And then the Vault API interaction is basically where the certificate service, which is the Lambda, which will call the Vault PK API endpoint, submit the CSR and all the other related parameters. And Vault then within intermediate CS sign the CSR and issues the certificate. And then at the end of the day, user is user is basically presented with a CA chain, a certificate, and then possibly, why not a private key if handled on the server side. And then the certificate service, once after receiving a CA chain from Vault, it basically responds back as an API response to the user. And then it user would have the JSON link, or it would have the download link for the certificate. And then the automatic import to certificate manager is also managed by this service, wherein we are using another Lambda to actually interact with ACM. And then we have an event bridge in place that can actually track the certificate expiration times. It can have, we can have, in this example, we had a Lambda, but we can also build a cron jobs on top of that, that can make sure that we get notified the moment the certificate is about to expire. And you can also reissue a certificate with zero manual intervention. We'll again have an expiry notification, where you will use services like SNS or SQS that can hook it up to your email, to your Slack, to your ticketing system for all the notification. And then, as I mentioned, we'll have CloudWatch based logging enabled to make sure that if anything goes wrong, again, this is an internal system and it could be possibly well compromised. I'm not saying that this is the most secure system that has ever existed, sort of ever, but it can possibly be compromised at some point of time. So the logging is to make sure that you can have all the logs, you can hook it up to your SIM, you can send it to your SIM, and then have all the alerting in place there. And then at the end of the day, the response to requester would be the CA chain, and then the leaf certificate key as well. One thing that I would like to add here is that uh, for this, you can also, like, for the end user, instead of presenting an API endpoint and API gateway, you can also switch to a Jira based workflow as well. And that's where sort of I have been doing some sort of research here and there, wherein you can use an orchestration platform like XOR or something like that. And then you can use a Jira based workflow, wherein a user submits a Jira request and user enters that, hey, I need a certificate for these are my details. And then the Jira workflow happens, wherein the request goes to, let's say, one of the approvers. Once it is approved, then it is basically your Jira or your orchestration servers like XOR that communicates to API gateway, and then all the things happen. So this will make easier for user to get a certificate, and the only thing that user would have to do ever is to just submit, I would say, a Jira ticket. And I think once that is done, it the whole thing happen on its own. And then again, the reissuance part is something where one Lambda can call the another Lambda after an event is observed to basically and a certificate expiration event is observed. So this is the whole idea of having an isolated root CA, an intermediate CA, and then basically building a self-service end-to-end automated workflow to basically get the, I would say, certificate issued by internal PKI. And yeah, that's all. So Any questions or anything any questions? Yes.
You're mentioning that you've got some audit logging there in case that certificate, that mechanism is compromised. So if your little Vault intermediate CA gets compromised, you want to make sure that it's issuing stuff you have. If you're just using effectively immutable logs, you're still counting on the fact that this compromised service
And
would
one thing I would
log
like to add
would
here,
log what it was doing.
while I'm waiting for the questions, is that this has been proved to solve one of our biggest problem, which is when a certificate or when a service basically wants to. So a lot of times when we deploy, our Kubernetes clusters, and when we run microservices based architecture, there are areas where our services needs a certificate all the time, right? The idea of reaching out to a public CA, as I mentioned earlier, is somewhat, I would say, is overhead. And then this architecture has been proved, at least at least for our use case, to basically solve that problem. So any service that for us, when it needs a very short-lived SSL certificate, is basically we were also able to solve that. Yeah. I'm open to any questions if you have.
What is your question, please?
Can you hear me?
He doesn't hear you. You just
Yep,
have to
I
say
can
your
hear you.
Just say the question.
Oh, okay. Your audit logging there, you were saying you've got an immutable audit log for the certificates that are being issued in case it gets compromised.
Sorry, yeah, I cannot hear you now. Can you please come again?
The audit logging, can you hear that? You've got an audit log for the certificates that are issued in case the service was compromised, correct?
A request to moderators, like I can hear their voice instead of the user who's asking the question. So I can hear the moderators, but I'm not the user who's asking the question.
Can you hear me now? No?
Yes,
Oh, okay,
I
you
can hear you.
Good. You've got your audit log there. It says it's immutable
Uh-huh.
in case your vault gets compromised, and you want to know what certificates it has issued. But the immutability isn't saving you from this, because if the vault service gets compromised.
To honestly answer your question, the second part, we are this design does not solve that. So if the vault is compromised and if attacker tries to issue certificate, this specific to this design, this is I would say an open challenge, and it would still think that the certificate has been issued by a genuine end user. So, I mean, if in a scenario where vault is compromised and where the whole end-to-end, token system is compromised, the service would eventually, think that that's a legitimate call. So that's a challenge which this design does not solve. But what we could do is, I'm hoping that if the auth logging to vault has been enabled, and then I mean, this problem is not hard to solve. It's just that this design does not solve that. I mean, yeah. To answer your first question, yes, we so within our compliance standard, there was a requirement that to have a backup of all the certificate, like in a scenario where HashiCorp vault is or goes down, and then if we want to retrieve a certificate, then that becomes a problem. And that's why things like ACM was used. And then the fact that the whole issue or reissue cycle becomes really easy with the ACM. The whole idea of using ACM was that because we could then use things like Event Bridge, and then SNS and whatnot, to get a timely notification around the certificate expiration, which was a little problematic when using HashiCorp Vault, but it could possibly use like you can use HashiCorp Vault as a certificate manager. To answer your second question, this the idea of using so many lambdas versus going to a private CA, well, it depends. There are certain scenarios, especially when it comes to reissuing the certificate, which we were not able to, or I was personally not able to solve with the private CAs. And then the whole idea of building a PKI engine was based on that. So, especially when there were services that were requesting certificates directly, we were facing bunch of issues while I mean services running in different clouds interacting with private CAs versus services running in different cloud interacting with just an I would say an internal API that can easily be uh, basically reach out to those services was easy to solve rather than doing that on the private CA. So private CA could be possibly used, but there were certain challenges that we ran into, and then we were able to solve uh, with this approach. Yep. Thank you all for your time, and thank you to all the moderators. Hope this was helpful. And then, yeah, thank you so much for your time.